Hi, my name is Pranav Kiraju, and this is Physics Lab 4 Oscillations. The purpose of this lab is to examine the motion of a spring mass system in which the mass swings in an arc while also oscillating on a spring, and compare the experimental data with the model generated from GlowScript. In this experiment, the system is the mass attached to the spring. Principles used. Throughout this lab, we are directly applying Newton's second law of motion, through which we get the position and velocity update formulas. We are also using Hooke's law to determine the F-spring. Additionally, we are also using the energy principle, which states that energy is neither created nor destroyed, but it can be transformed or transferred. Here you can see is the preview of the results obtained from the lab. On the top left, we have the x position versus time, and on the bottom left, we have the y position versus time. Additionally, we also determined the periods of oscillation for x and y to be 1.684 and 1.53 seconds respectively. Procedure. Using the tracker software, I tracked the position of the spring mass frame by frame in an interval. Through the tracker software, the x and y positions were determined and subsequently imported into an Excel CSV file. Then, using the starter code provided, I created a computational model based on the physics principles such as Newton's second law and the energy principle. Then, I uploaded the CSV file to GlowScript and compared my experimental data with the computational data. Here's the marker motion using the tracker software, where I used a pre-recorded video of a spring mass oscillating back and forth. I set up the calibration stick and tracked the motion of the spring mass using the center of mass tracker, and obtained the x and y positions over an interval. Here you can see is the starter code that was used to create the computational model for the experiment. In the starter code, we set the object's position and velocity, and compute the system's energies in order to predict the motion of the spring mass. This is the first output of the computational model, where you can see the various energies in the system at play. The main takeaway from this is that, as seen in the center orange line, the change in energy is 0, which is the output that we were looking for. Now, as you can see, here's the comparison between the experimental data obtained through the tracker software and the computational model from GlowScript. While both are very similar, there is an observed deviation in both cases. Sources of error. As it is a simulation, it is not entirely accurate and it does not take into account other external forces, for example, the man pushing the spring mass too hard, etc. Second, inaccurate tracker software placements such as calibration sticks, center of mass, etc. What does it mean? Part 1. For your model system, is the energy principle satisfied? As we discussed earlier, the energy principle is satisfied. This is because when the graph below is observed, we can see that the orange line, the change in energy, is 0, which indicates that the energy principle is being followed. What does it mean? Part 2. The period of oscillation from the x position data is 1.684 seconds. Meanwhile, the period of oscillation from the y position data is 1.53 seconds. The period of oscillation for the x position is a little more than for the y position. The values are very close, but there are various factors which cause the differences, such as tracking inaccuracies and more motion along the x-axis as compared to the y-axis. Thank you.